they do and how do we use them. So we're going to go ahead and look at a few things today. We're going to look at 3 subassemblies, the LinkProfileControlled, the CutFillProfileControlled, and then the DaylightProfileControlled. We're going to look at those 3 subassemblies. And then we're also going to look at subassemblies and how to get them to use Superelevation. So with that being said, we'll go ahead and get started. Actually, before I start, if you have any questions, go ahead and throw them in the chat in there, since we won't have audio for everyone. Go ahead and just throw some questions in the chat. We'll do our best to get to them as they come up. But let's go ahead and get started. So the LinkProfileControlled, it's got some input parameters. The basic, what side, left. We have some output parameters for the slope and the width. So if we have things that are built after it, we'll be able to use the exact same slope, the exact same width. But you'll see the width, the slope, and the omit link are 3 parameters that we can plug in there. And then we have 2 point codes that we can customize, and we have a link code that we can customize. So pretty basic right here. Link profile, it's link width and slope, but it gives me the ability to target the width. So I can target that. So maybe instead of 4 feet, I need to vary it from 4 out to 10 and then back into 4. But elevation targets, I have an elevation target. So typical, my slope, maybe it's constant 4 feet, but now I'm going to vary from 30%, 3 to 1, to 4 to 1, 25%, give or take in there, and I can adjust the elevations. But the key thing with this subassembly is the slope from profile or the width from profile. I have the ability to assign a width target based off of a profile view. And I also have the ability to adjust the slope of the link width and slope to a profile. So the behavior, the width from the profile target, the width of the link will match the elevation of the profile. So if I have a profile view and it's going from 4 up to 10 feet back to 4 feet in elevation, it will use that as a width target. And now the link width and slope will vary from 4 out to 10 and then back to 4. The slope of the profile target, the slope of the link will match the elevation of the profile. So very similar to the width. Now if I have the slope of the link, it will match that exact same elevation of the profile. Offset horizontal alignment. Horizontal, the width of the link will match the offset of the alignment. So I can target the width to follow something horizontally. There is priority or hierarchy when it comes to the targeting. Target options take precedence over the width parameter. So when we were back here, I had a width of 5 feet and I had a slope of -3 to 1. Well, if I assign any target in here, in any of the places, that target will override the width. Pretty straightforward. That's pretty common on all subassemblies. But the main thing is the width target takes priority over the width from profile target. So if I assign a target here in the horizontal and I assign it down in the slope or elevation target, my width, my horizontal one, will take precedence over that one. So if by accident you accidentally do assign 2 targets for the same result, it will take the width in the horizontal over the width from profile in the elevation targets. Same thing with the vertical. Target options take precedence over the slope parameter. So I have my slope 3 to 1. If I assign any target in there, that target, the elevation or the slope from profile will take precedence over the user input. And then the slope target takes precedence over the slope from profile target. So again, this elevation will take precedence over the slope from profile. If you were to assign them both a target in here, we would get the elevation, not the slope from profile. So In a nutshell, the link profile control, pretty straightforward. I can assign in the input parameters, I can assign a width, I can assign a slope. I can then go into the targeting capabilities and target the horizontal distance to an alignment to a polyline, or I could actually target the horizontal based off of a profile view, and then I could do the same thing for the slope. The cut fill profile control. I have a handful more input parameters. I see the side. I see cut or fill. Cut, fill, check, offset. Offset to measurement and recoverable slope. Recoverable slope, clear zone distance, recoverable fill slope distance, omit daylight link, cut slope, fill slope, and then 3-point codes, 2 link codes that we have the capabilities in there. The key ones to look at here are the cut or fill, and then the cut, fill, check, offset. We'll look at those here in a second. Targeting capabilities for the cut, fill, profile controlled. We're looking at cut, fill, check, offset, clear zone, offset to measurable, measure recoverable, recoverable fill offset. Vertically, we're looking at the cut, fill, switch, cut slope from profile, fill slope from profile, recoverable slope from profile. So I have a couple targets in here. Again, you will see cut slope or fill slope from profile, and then the recoverable slope from profile I have in here. This subassembly is designed to accommodate a clear zone with a basic cut or fill configuration. The parameters that come into play is the clear zone distance. It's used in a ditch scenario. The recoverable fill slope distance is used in a fill scenario. When entering the clear zone, you should enter the full value in there, not just, oh, let's go halfway in there. Back in the cut fill input parameters, there are 3 options on there. There is automatic, there is cut, and there is fill. So cut, fill options are automatic, cut, or fill. What this does is it will compare the attachment point elevation with the target surface elevation at the offset specified by the cut, fill, check, offset input parameter. So what that does is, first, it says automatic. What that will do is it will determine, hey, based off of this offset parameter, am I higher or lower than the EG surface or my target surface? And if it's automatic, if it'll say, hey, I'm in a cut if I'm below, and I'm in a fill if I'm above. If I'm in just cut, it'll always want to try to do a cut scenario. And if I say fill, it'll always try to do the fill scenario. And again, this is always going to check the target surface, our daylighting surface elevation at the offset specified by the cut, fill, check, offset. Well, that cut, fill, check, when the value is set to 0, the surface elevation is taken at the attachment point. So right here, my cut, fill, check, offset is set to 0, so it will look at the elevation right there at the attachment point. If I were to put in 2, it would actually come off the center line 2 feet and check the elevation there. If I put in -2, it would go to the left side 2 feet and check the elevation there. But by having that cut, fill, check, offset set to 0, it will look at the attachment point. So in a fill section, the recoverable fill slope distance and recoverable slopes are used to temporarily construct that first fill link. The endpoint of this link is called a test point. The recoverable fill slope distance in most cases is measured from the edge of the topmost pavement layer. So typically the edge of travel way. This offset is measured, this offset is the offset to measure recoverable slope from, and can be entered by the user either by the input parameter or by the horizontal target. So if I come in there is my offset to measurable recoverable slope and the distance. And I can plug those values in. So, or I can target. Recoverable fill offset is right there. I can either user input via input parameters or through the target parameters. So based off of my offset, typically from the edge of travelway, and then the offset distance set to 0 will go to the attachment point. That test point right here, if it's above the daylight surface, the first recoverable fill slope link is inserted. The end of this link is the rotation point. If it's below the surface, the recoverable fill slope link will end at its intersection with the daylight surface. It will come in and fill to that the daylight surface. So here is a typical fill section. We had the recoverable fill slope distance, again, typically from the edge of travelway. Came out because this was above. It did the slope intercept and it went straight through there. Now, with the fact that I can go in and go back to here, the cut or fill, I can set that to always be cut. I can always make it set always to fill. I can actually come in and force the fill section. So what you see here is, again, the same recoverable fill slope distance, and it's below. Now what it's going to do, instead of filling to get up to it, it's going to just continue straight through at that grade until it actually finds the slope intercept. Now, if it doesn't find that slope intercept, it will actually just put this basic link out there and throw an error message on there for you. So in a cut section, the clear zone distance and the recoverable slopes are used to, again, temporarily construct that first fill link, actually cut link, typo on my part, but the end point of this link, again, is called the test point. Again, the clear zone distance is usually measured from the edge of travelway, and this offset is the offset to measure recoverable slope from, and can be entered by the user or by a horizontal target. So again, the offset measurable recoverable slope is right here, offset to measurable recoverable slope from. I can plug that in, or I can just plug in 0, or I can actually use the horizontal target for that. Again, with the test point, if it's below the daylight surface, the first clear zone link is inserted. If it's above the daylight surface, the clear zone link will end at the intersection with the daylight surface. And here is an example of a forced cut section. So again, it found out the clear zone slope distance from the edge of travelway. It calculated that. It said, hey, I'm above, but I did a forced cut. So it continued up until it found the slope intercept. At that point, it ended at the daylight surface. If we forced it to a cut section and it did not find a slope intercept, again, it would throw in a single link and it would throw an error saying that it couldn't find it. The daylight profile control, our third subassembly in here. It has a lot of the functionality of the CutFillProfileControlled subassembly, but with the daylight profile control, this one will actually give me the ability for a ditch or a berm. So what I can do is I can have it build a ditch, and then it can actually build a berm on the outside of the ditch. 2 extra features above and beyond that CutFillProfileControlled. So you will see in the input parameters, you will see the ditch fill switch, automatic. Again, you'll have a ditch force, you will have a fill force in there, or automatic. The check offset, again, that will look at the attachment point when it's set to 0. If it has a value plugged in there, it'll look at that from center line. Offset to measure recoverable slope. That is typically what your edge of travel is going to be. So we have those adjustments. Recoverable slope, clear zone, recoverable fill slope, connecting link slope. Now that we're into the ditch, because we can build a ditch in this one, we have for slope with the actual slope, the bottom of the ditch, and then we have calculations for the berm. How high is the berm? That height of the berm comes from the bottom of the ditch. So if my edge of travel way, and now my bottom of my ditch is 2 foot higher, and I make my berm positive 2 feet, the top of my berm is going to be the same height as my edge of travel way. So the berm height, just to note, is from the bottom of the ditch, but the width, berm top slope, and then omit daylight link. The ditch back slope, the daylight fill slope, the minimum 3D length, they're all in here. And then you'll see that we have 9 point codes that we can customize, and we have 8 link codes that we can customize. This is the benefit of a custom subassembly with all 3 of these, is that I have the ability to come through and customize these codes. These codes, when linked with the proper code set style, will allow our corridor to build properly and to visually be what we want to be displayed. So having these customized codes in here just makes things look the way that we need them to look. So our input parameters, like I said, very similar to the cut fill, but now I have the ability to do a ditch and a berm with this one. So the target parameters, I have the ditch fill offset. Again, that's something that can be plugged in at 12 foot, or I could actually say, hey, target this line to determine my offset. The clear zone offset, the offset to measure recoverable, and then the recoverable fill offset, those are my horizontal. And then my verticals, I have berm elevation, top slope from profile, berm top width from profile. Again, I have those abilities to target a profile for something horizontal in terms of the width. The slope, again, I can target a profile. Ditch fill switch, you have the ability to target that profile. And we'll see the results of this in a little bit. And then I have a handful of other things, connecting link slope from profile, ditch back slope from profile, ditch bottom width from profile, ditch elevation, ditch for slope from profile, ditch for slope width from profile, fill slope from profile, and then recoverable slope from profile. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9 targets in there that I can target a profile, and they're not all just elevation targets. Some of them are horizontal targets. So the behavior of the Daylight Profile Controlled, it's designed to accommodate a wide variety of clear zones, ditch section, and fill section configurations. Allows you to target a profile elevation for the ditch point. Gives you the ability to construct a berm depending on the scenario. Your parameters, the clear zone distance, again, used in a ditch scenario. The recoverable fill slope distance used in a fill scenario. Again, very similar to the cut fill profile controlled. The ditch fill switch, again, just like the other one, has the options of fill, ditch, or automatic, whereas the other one was fill, cut, or automatic. But in both situations, the automatic option compares the subgrade shoulder point elevation with the target surface elevation at the offset specified by the ditch fill check offset parameter. So basically, the subgrade shoulder point, almost the attachment point, will compare the ditch fill check offset parameter. If this parameter is set to 0, the surface elevation is taken at the attachment point. typically the subgrade shoulder point. So there is my attachment point. And so the ditch fill check offset, set to 0, links it to the attachment point. Now, the one thing that makes this unique, very similar to the cut fill, is that ditch fill switch. When you target a profile with this, it doesn't look at anything but is the number greater than or equal to or less than 1. If the elevation is 1, by default, it says it's automatic. So then it will go back to the real life scenario. Am I in a ditch situation or am I in a fill situation? If the elevation is less than 1, it will force that subassembly to build as a ditch logic. And then if the elevation is greater than 1, it forces that subassembly into a fill logic. The same thing can be said with the CutFillProfileControlled with the profile. 1 is automatic, less than 1 is cut, greater than 1 is in a fill. And when you are targeting the profile and you actually use the ditch fill switch in there, so maybe I had the switch set to automatic, but then in my targeting I targeted a profile, it will override that switch. Just like we mentioned in the other ones, the user input will be overridden by any target parameters. And that's what we're saying here, is just because I said ditch fill set to automatic, but if I go back and I then target a profile for that switch, that target will override the input. So in a fill section, the recoverable fill slope distance and recoverable slope are used, again, to temporarily construct that first fill link. The endpoint of that link is considered the test point. The recoverable fill slope distance, in most cases, is measured, again, from the edge of travel way. This offset is the offset to measure recoverable slope from, and it can be entered, again, either in the input parameters or by targeting it horizontally. And if the test point is above the daylight surface, that first recoverable fill slope link is inserted. The end of this link is the rotation point. If it is below the daylight surface, that recoverable fill slope link will end at its intersection with the daylight surface. So this is a typical fill section where it came in and it found the recoverable fill slope distance, and it either stopped at the rotation point or it continued on with the fill length. So again, if it was above, it's known as a rotation point. If it's below the daylight surface, the recoverable fill slope link will intersect. So typical fill section. Here is a forced fill section in there. It came through and it says, well, I'm below, but I forced it to find the slope intercept. It found it. Again, it will throw an error if it does not find an actual slope intercept. In a ditch section, the ditch force slope and the ditch force slope width are used. A ditch link is then inserted using the ditch bottom width parameter. The clear zone distance, it's used to determine if the clear zone link is inserted. In most cases, it is measured from the edge of the topmost pavement. So again, the edge of travel way. If it falls outside the outside ditch point, a temporary link is constructed from the outer ditch point using the ditch required to obtain the clear zone distance and the recoverable slope ending in the test point. The test point, again, above the daylight surface, the clear zone link will end at the intersection with the daylight surface, becoming the slope intercept. And if it's below, the clear zone link is inserted. So here is a ditch section with a flat bottom ditch and the clear zone inside the ditch point, and it builds as we see here. Here is when it falls outside of the ditch point. And so we see that there's inside, there's outside. Here is the ditch elevation higher than the target surface with the slope intercept found. So here we're forcing it to be in a ditch, and it came in and says, yep, I found you. And this is what will happen when it could not find. The cut slope has no intercept. It actually then found a berm top slope. So it came through, and then the berm top slope. Cut slope has no intercept found on a berm fill slope. So we come down, came up, over for the width, and then we ended up doing a fill slope on the back side of the berm. All of this is capable within that daylight profile controlled subassembly. When you force the ditch section, some results there. So in a nutshell, those are the three subassemblies. I'm going to go ahead and we'll continue with the PowerPoint, but I'm going to jump into the software and show you some of the tools with that Daylight link or that Daylight Profile Controlled. But before I do that, subassemblies and superelevation. In 2018, there is a stock subassembly, the Lane Superelevation AOR. It is built to work in tandem with the Superelevation Wizard built into Civil 3D. The WisDOT Subassembly library, it's not built to use these functionalities, which is the basic potential pivot, slope direction, all those things that you will see in that Lane Superelevation AOR. The WisDOT Subassembly library has tools and features built into the subassemblies that has things already set up to control what's needed for the design. It's basically built into the lane and shoulder logic on how it handles superelevation. So when you're using the superelevation, or your road has superelevation, there's a couple ways to build your subassemblies or through the wizard. So within the wizard, the alignment superelevation should be developed in the superelevation wizard as follows. So typically undivided crown is what we're after on here. And then when we go to lanes, set the lanes, number of lanes, 1, 2, potentially 3. Nominal width, nominal cross slopes. Nothing's out of the ordinary yet. When we get to the shoulder control, the shoulder slope treatment, we should set the low side to break over removal and the high side to be match lane slopes. So there's one little thing that we do in there when we're dealing with the wizard. And then the attainment. The superelevation rate table, and then the transition length table. We need to change those to match the FDM transition table and the roadway typical section. So other than that, changing the shoulder slope treatment and then the attainment, the wizard's pretty straightforward. Now that we've run the wizard, we need to make sure that our subassemblies are actually set up properly so that the logic built into them is utilized properly. Because if you don't set both up properly, the wizard and then the subassembly, it can throw a handful of errors out at you because it says, I don't understand. So first, remember to run the superelevation update, and you'll have the baseline superelevation properties needed to use for the WisDOT subassemblies. The undivided crown superelevation setup, for most cases, will work in the general roadway design for WisDOT. So that undivided crown, back from the first screen, should work in most situations. What happens if my road is just a single lane ramp or maybe a loop. Well, in my ramp, I got my lane generic right. What I want to do is in its properties, I want to use the superelevation type, use outside lane superelevation. And then subgrade superelevation method, follow pavement. Pretty straightforward on a single lane for the lane. The shoulder for that single lane, paved shoulder, use outside shoulder. Unpaved shoulder, match paved shoulder slope. And then the subgrade method, use outside lane. Those are the 5 things that you need to switch or adjust when you're dealing with a single lane ramp to build things properly. And then the last one is just for the other side of the shoulder. We're going to adjust the same 3, but it's use outside shoulder, match paved shoulder, and then use the opposite side lane in there. So that's how typical assembly will be set up to build a single lane ramp or loop. If you're talking about an undivided roadway, your lanes are going to be use outside lane and follow pavement. The shoulder, use outside shoulder, match paved shoulder slope, and then use outside lane. Pretty straightforward on that. Very similar to the single lane. Now, if you're talking about a divided roadway, we're going to do crown location. We have to worry about the super elevation type. Use the opposite side. Outside lane, SE multiplied by -1. Fixed slope for top of pavement, 2%. Subgrade method, follow pavement, and then the fixed subgrade slope, 2%. The other lane, inside, outside, follow pavement. So I have lane 2 is the outside, use the opposite side, but lane 1 is the inside, super elevation, use outside lane SE. So lane 2, lane 1. The shoulder, use outside shoulder, match pavement shoulder slope, use outside lane for the 3 steps there. And then the shoulder constant width on the median side, again, use outside shoulder, match pavement shoulder, use outside lane. Pretty straightforward on using these subassemblies for super elevation. You just have to remember which one to use and when to use it. So I'm going to go ahead and jump into the software. And what I've done is I built a fake surface in here. It's got some relief in there, and built a proposed profile 1, 2, and 3. And then I came through and built a corridor 1, 2, and 3. One being with the daylight, one with the cut fill, and one with the link slope. Well, the one I really want to look at is the daylight one. So I'm going to quickly click on there, and it's saying it's assembly 1. And this subassembly is the DaylightProfileControlled. So if I come down into my corridor and go into section editor, Let me switch my view. And we'll go to 3 above. Then if I switch, it's got 3 assemblies in there, or 3 alignments, 3 profiles. And I built one for each of the sub-assemblies. And now if I look at like this one right in here, I can see that I cross over like 2 times at one at 1 plus 10 and another one around 4 plus 90. So when I jump into my corridor drawing, I can build a corridor out of that alignment and profile. And I'm going to use this subassembly right here. And it's called Assembly 1. And it's called, there is my DaylightProfileControlled. And if I just build it as is, my corridor looks just fine. So I'll come into Section Editor, and we will take a peek around station 4 plus 90. And so I'll jump up around 465. And you can see that, yep, my center line is below. And as I start moving, now my center line, when I'm at 5 plus 0, has now gone above the EG surface. And the target elevations have all been based off of my attachment point in here. So even though I'm above here and I'm below here, these values are set based off of the attachment point on whether it's a ditch, or if it's a ditch with berm, or if I'm in just a flat out fill situation. So when I get completely above, now that my attachment point is above, now I go to a fill. So depending on the terrain and where I attach at is going to make that distinction. Now what I can do is I'm going to close out of my section editor, is I can come into the properties of my Daylight profile and say properties, and I can force it. Oops, sorry about this. Let me quickly go back into the corridor, because what we were seeing was that switch going on, and I forgot to switch it back. In my targets, I actually targeted a profile in there. So that's why we saw it switch from cut fill, and this is where it made that switch. I'll do a quick little look at that profile view, and at 0, 0, the value is set to 0. So from 0 to basically 4 plus 50, because there's I am less than 1 when it comes to the profile view. Well, what this does is when it's less than 1, I go to a ditch situation. When I'm equal to 1, it's automatic. So it'll make that decision on whether or not should I be cut or should I be fill. So from 450 to 7, it's giving me, it'll determine, am I in a fill or am I in a ditch situation? And then everything from 7 plus 0, 0 to the end station, because that value is now greater than 1, it says automatically go into a fill. So let me go back to my section editor in here. Section editor. And we will see that 350, I'm in a ditch. Still in a ditch situation. Now I'm at 450, so now my value equals 1. So now it will actually read the value all the way through, and it would determine, hey, should you be cut or should you be or ditch or fill? And then anything over 700, there's 700 still equals 1, so it's going to be automatic. So it says, yep, fill. And now the rest of this is saying, yep, always do a fill. And this is what we're seeing on the left-hand side, is that the fill doesn't work, or because it's not finding the proper situation. So if I go into my subassembly, or let's actually go into the corridor property first. Corridor property, set our targets. We will remove that target. Now the user input will have a say in it. So now I could come in and on the right hand side, subassembly property, we'll go just property. And instead of ditch, well, let's just use ditch for the right hand side. Rebuild my corridor. It's already rebuilt. I got it set for automatic. Section to editor. Now I'm always wanting to be in a ditch no matter what scenario I'm in. Even though I was in a fill situation right here, it built the ditch, and then it built the berm, and then it daylighted with a fill slope. So I can very easily force a ditch. I can force a ditch with a berm. All depends on what parameters I set in the properties. If I set it to automatic, if I'm in a fill situation, it's going to do a fill. If I'm in a ditch or a cut situation, it will build the ditch. But if I switch it to ditch or fill, one of the others, it will force it to work that way. And if it finds the slope, it'll intercept. If it doesn't, it'll throw that error for you. So we'll open that back up, and I'll throw my conclusions out there one more time. The daylight profile controlled, it's intended to work with clear zones, target horizontally and vertically. You can force the fill or ditch scenario with a profile. Cut scenarios can build a ditch and a possible berm on the backside of the ditch. The cut fill profile, very similar to the daylight. You just don't get the ditch or the berm, but I can still force a cut or fill scenario, and then target horizontally and vertically. And then the link profile control, set the width with the alignment and or a profile target, and then set the slope with a profile target. So the link profile, the simplest of the three, but still has a lot of power to target horizontally and vertically, and then target horizontally with a profile. The key thing on here is all three have custom point and link codes. So I'm allowed to utilize my code set styles to display my assembly, my corridor, or such the way that I need to have it displayed for that portion of the project. When would I use them? The linked profile, basically anytime you use the link width and slope with a varying slope or width. The cut fill profile control, projects that you need to force a cut or fill. Control the transitioning slope with a profile line. And then adding in all the critical FDM required breakpoints and standards. The daylight profile control, again, just like the cut fill, but when I need a ditch in the daylighting area. So that's when I would use the three. And then just note that the Wisconsin Subassembly library, it's not intended to use the potential pivot and some of the same parameters as the Lane Super AOR out of the box subassembly. The Wisconsin DOT library, it has the built-in logic in the lane and shoulder already. You just have to make those minor adjustments. And for more information, there are some links right here that will take you to the subassemblies and Superelevation, and then the other one for the subassembly help, and then you can pick on any of the subassemblies that you do need on there. So now we'll open it for questions, and this is where I found out that I had been kicked out. So let me yeah, it looks like most of the questions are, hey, we lost your screen or you froze. So I'm going to say that I don't have any questions at this time.
Scott, this is Keith Sawinski. I just have one comment to add, other than we did a good job, especially recovering from that technical malfunction. Just letting everybody know that we are adding some additional functionality to CutFillProfileControlled and also DaylightProfileControlled. We're going to be adding the ability to handle multiple possible slope intercepts. So right now, those subassemblies, they just kind of daylight to the first slope intercept they encounter. Now you'll be able to choose, if there's more than one slope intercept possibility, which intercept you want to choose for your final solution. And that will, you'll be able to do that in multiple ways. You can either just put in a number, say I want the second intercept or third or first or whatever. You'll also be able to choose which intercept with a profile. So the profile elevation will represent the intercept number, and then that will be the intercept that the subassembly uses. And finally, you'll be able to choose the intercept by a width parameter. So you can target an object, a horizontal object or a profile object that will represent the furthest intercept that you want. So maybe you have multiple intercepts that are possible, but you want the one that's at least 30 feet away from your baseline. Then you can target an object 30 feet from your baseline, and it'll use that intercept. So a couple enhancements to look forward to. We're working on that right now, and we're expecting to have something later this summer for everybody.
That'll be nice to see. Matt, Andrew, do you have anything to add?
We should be good, Scott. Thank you very much for presenting. We do have a survey that'll be following after this too, that either I'll send out or Andrew will send out, just to get a little bit of feedback on how everything went, and any topics that anybody would like to see in the future as well. So if you guys got something that you want to see or want to learn about, just let us know, and we'll try to do that next time. So thanks again, Scott, and awesome recovery. So you did well. Thank you.
All right. Thanks.